So review questions for Chapter 7 and 8 here. Chapter 7 was on exponential functions, as you recall. And number 1 says, consider the exponential functions of y equals 4 to the x and y equals 1/4 x. So 4 to the power of x, that has a base that's greater than 1. So this is going to be an increasing function, right? Increasing function. I'll just roughly sketch it right here. This is always 0, 1, right? And 1/4 x is 1 over 4 here. So this is a similar function, but it is a decreasing function. So it's kind of symmetrical here. I'll draw that as symmetrical as I can. Now, sketch the graph. Some points would be, if I did black here, so x and y. So if x was -1, y would be 1/4. So -1, 1/4 is right here. 0, 1, 1, 4. Okay, so 1, 4. And for the red graph, x, y, -1. So 1/4 to the -1 is the same as 4 to the 1. So -1 goes up to 4. 0 is 1 and 1, so 1/4 to the 1 is 1/4. So that's how you get the red graph there. Now it says compare the domain, range, intercepts, and equations of the asymptotes. So if we're going to compare between these two graphs, I would say, and you should say here, that the domain is XER. That's all real numbers for both. The range is y. What's the range for these ones? They're both the same. It's y what? Greater than 0. Not or equal to, because it never touches the x-axis here, but it's greater than 0 for both. Okay, let's fix that. The intercepts. Okay, so y-intercept is 0, 1 for both. Equations of the asymptotes. Okay, do you remember what asymptotes are? They're kind of the imaginary lines, either vertical and or horizontal, where the graph does not cross or touch that line as x gets extremely large in the positive or negative direction. A graph can actually cross over an asymptote line when x is small, but as x gets to infinity, a horizontal asymptote, it would slide right alongside that asymptote and not touch it or cross it. So we have a horizontal asymptote here, and that's at y equals 0 for both. Okay, I guess as far as those, they're the same, right? Yeah, everything's the same for each of those. Okay, C then says, is each function increasing or decreasing? Well, we said that already. This is increasing right here, and this is decreasing. And that's because the nature of the base here, right? If it's greater than 1, it increases. If it's between 0 and 1, it is decreasing. Okay, any questions about number 1? All right. Number 2 is a matching one. Number 2 is a matching one, so this has got a little bit of everything in here. I wouldn't say this is a super easy one, it doesn't look like, but all right, what it looks like here for A is we have some kind of increasing function, right, that has an amplitude or an A value of 5. So the intercept would normally be 0, 1, right, but it's times 5, so it looks like it's going to be, it's stretched, so the intercept still stays the same there, but it's stretched up, but it's then moved up 1 unit. So the y-intercept turns into be 0, 2, looks like. So do we have a 0, 2 intercept? 2 to the x was 5 plus 1. Make sure I got the right question here. Hang on. All right, so the 5 here stretches the entire graph. Every y value is times 5. So yeah, so this would actually go, every value it would be times 5 up like this, I guess. So yeah, my bad there. So this one stretches up like that. So the 0, 1 becomes 0, 5. And then it's up one more, so it looks like it goes up to 0, 6. So is there something close to 0, 6 here? This one's close to 0, 6, so that might be, that looks pretty good. Okay, a horizontal asymptote would be at y equals 1, which looks pretty close there too. So it looks like A is B. B here, this one here is, it's a decreasing graph. So it's going to come down. It's going to come down. And it's also going to go left 5 units. So it's decreasing and it's going to go left 5 units. So 0, 1 would be over 5 units, looks to be about here. So this one looks to be D, I would say. Okay, so number C, if we isolate for y, this would be 2 to the 5 minus x minus 1. So you have an increasing function, 5 minus x. Okay, so that's different than x minus 5. That's negative x plus 5. So negative x plus 5, if that's an exponent, the negative looks like it switches around left, right. Okay, so we have an increasing function, but it's switched around left, right. So instead of going like this, it comes like this, right? And it's moved down 1 unit. So a horizontal asymptote of 0 would be negative 1. And x equals 0, if you just plug in x equals 0 here, so y equals 2 to the 5 minus 0 minus 1. That's y equals 2 to the 5 is 32 minus 1. Should be about 31. Now this one's tough to tell. I think it's got to be this one here. This looks like it goes through 32, but technically it looks like it's going through 31. So this one would be A. C would be A. And then the only one left is C. Okay, this is a decreasing function, but it's flipped around the y-axis. So decreasing, and it flips. So it actually looks like it's going to go up, increasing. And times 5, so 1 times 5 should put it there, so that's C. Okay, any questions with that one? Okay, so this is, what section was this again? This one's 8.3, right? Each expression is a single logarithm in simplest form. Okay, so what we have here is, you might want to rewrite this as 1/2 log of x base 3. Okay, 1/2. That'll, because this coefficient now can be written as an exponent, right? So you might want to rewrite that. This one here, the exponent goes on the y, so it's minus log of y base 3 to the power of 2. So you okay with those first 2 steps? Okay. So now, because we have logs with the same base and they're subtracted, what we can do is divide these things. So we have log of x to the 1/2 is the same as, you can write it as root x over y squared to the power of 3. Single logarithm, simplest form, I think you're fine there. If you want to write it as 1/2, I think that's good too. That looks to be, I think that should be the answer there. Okay.
How'd you get the 1/2 as the exponent?
This 1/2 is an exponent. Well, that came because it was a coefficient here, and it's a coefficient there because it's like 1/2 here. So yeah, you bring that out as a coefficient, you can kind of see that, yeah. Okay, I had a question over here first, sorry. Number 10, did someone say?
On this,
Still have a question about this one?
yeah.
Okay.
How do you get the square root of x again?
Well, again, because this up here divided by 2, right, is the same as multiplying by 1/2, which I did here. And because of the laws of logarithms, a coefficient in front of a log can be written as an exponent here. And x to the 1/2 is the same as square root of x. So you can write it as x to the 1/2 as well, doesn't matter. Usually I think they write square roots instead of fractional exponents like that, but 1/2 is the same as a square root, so that's why I did that. Okay, answer your question? Okay, which? 20A, and you had number 10? On the same section? Well, let's see what I have here. Okay, I got 10. Let me take a look at 10 here with you. All right, so 8.3 number 10, write each expression as a single logarithm in simplest form, stating the restrictions. Okay, similar sort of thing. You have two logs here with the same basis, so log rules or log properties apply. They're added, so x times this. We can write as a single logarithm there. Oops, let me go blue. So this can be written, the first two here, can be written as log of x times, now root x cubed, that can be written as x cubed to the power of 1/2, right? Because that root, which is the same as x to the 3/2. So this is x times x to the 3/2. Now with this subtraction, again, log same base, that 2 can be written as a squared. So guess what? I can also divide by x squared with a base 5. So, well, you should simplify this further. I'm not sure what the textbook shows, but this is not simplified. The reason why is because when you multiply variables with the same base, you add the exponents, and then if you divide, you subtract the exponents. So really it should go 1 plus 3/2, which is 5/2, minus 2, which is 1/2. So if I did that all in my head right, so 2/2 plus 3/2 is x to the 5/2, and x squared here, so 5/2 minus 4/2, which is what 2 is going to be 1/2. So that's log of root x base 5. That, I think, should be simplified, or x to the power of 1/2. Is that what the back of the book says? Yeah. Okay. Okay, so number 20, you asked about A? Yeah. A? All right, so prove each identity. Okay, so proving, you guys know what proving is like. What you have to do is you have to use any properties of logarithms that you can, and you want to just work on one side, right? Only. Unless you run into a problem and you can manipulate the other side as well. You can work on both sides, but you want to not mix the sides, right? We're not assuming equality. So this one's a bit of a challenging one. It's part of your assignment, so I want to do all of it for you, but you want to rewrite this using properties of logs. So one of the things that you can do is write this using the change of base formula, because notice the bases aren't the same. That's q cubed and just q. So you can write this as log of p cubed, okay? And you can choose any base, actually. You can choose any base. So if you choose the base q, then this would be log of q cubed base q. All right, and you're trying to make it look like this right here.
What was the base? Q.
Yeah, you can choose any base. Remember, with change of base formula, it can be anything. You can choose any base. You can make it anything. Yeah, you could, I guess. But remember, you're trying to make it look like this side over here. So change of base formula, your C, the new base and the logs can be anything.
Isn't that like it?
That's not it, no.
Oh, but once you do, oh wait.
So what would you do next?
P and a Q.
What can you do with this 3 and this 3? You can put down front, right? So now you have a 3/3, right? So what can you do with that? That cancel out, right? Divide out. Okay, so now we're getting pretty close. These are, I mean, can you rewrite this one so it looks kind of like that, or? I mean, I could have chosen, okay, so we didn't have to choose that. We could have just done this. We could have just done 10 too, right? Because now over here, that's maybe looks a bit easier. Log of P over log of Q, change of base formula again. See, now they're the same. Yeah, so change of base formula is the big one there. the power, sort of the power rule there. Okay?
Can you scroll up to 10 again?
Yeah, so back here with these q bases like this, right? This log of q base q is 1. Yeah, excellent point. So because that equals 1, then you have log of p base q, log of p base q. That's another way you could do it, you bet. All right, let's get back to that cumulative review. I'll go back there. So this one's number 3. This is also from chapter 7, working with exponential functions. So the number b of bacteria in a culture after t hours is given here. How many bacteria were there initially? Okay, so initially would be probably where t equals 0, I would say, right? So the number of bacteria at time 0 would be 1,000 times 2 to the 0 over 3. So 2 to the 0 is just 1. So it looks like there's 1,000 bacteria initially. So bacteria at 0 time. B, what's the doubling period in hours? Okay, so doubling period, I guess what you could do is instead of, let me just get back here. You could put 2,000 here as the future bacteria population, and then solve for t. If 1,000 is initial, then double. How long would it take to get double of 1,000? So this is going to be divide both sides by 1,000. That's 2 equals 2 to the t over 3. And because you have the same base here, 2 to the 1 equals 2 to the t over 3. So 1 equals t over 3. T equals 3. So it looks like 3 hours they would double. How many bacteria are present after 24 hours? You just put 24 in for t. When will there be 128,000? You just put 128,000 in for bt. All right, so number 5, 6, and 7 from the cumulative review. Write the expressions in each pair so that they have the same bases. Okay, so for 5a over here, 2 to the 3x plus 6 and 8 to the x minus 5. Well, 8 can be written as a base of 2. So this is 2 cubed to the x minus 5, like that. So this is 2 to the 3x plus 6 and 2 to the 3x minus 15. So that's your answer for A there. Number 6, solve for x algebraically. You could do 2 different things. You could use logs, but you don't have to really in 6a, because if you do 5, if you bring that 3 over, you see you have 8 equals 2x plus 4. 8 is 2 cubed. Now that you have the same bases, it's just 3 equals x plus 4. Negative 1 equals x. All right, let's go over solving graphically. All right, so let's take a look here at number 7. It says solve for x graphically. Round your answers to 2 decimal places. So in chapter 7, we didn't really know about logs yet. So you could do this using logs, which I probably will do right after this. But if you're asked to do this graphically using technology, this is what you would do. You would literally type in the left side as one y equation. So you go 3 bracket 2 to the power of, and you probably want to use brackets here, x plus 1. So that's the left side. And the right side would be 6 to the power of negative x. Okay, and once you plug those 2 in, I don't know what your window would be at, but if you just did zoom 6, probably a good chance it'd be close. And there we go. It looks like we have an intersection point right here. If you want to zoom in, you can. Zoom 2, zoom in, and notice in the zoom in you have a little cursor. If you move that cursor over and put it where you want the new center of the screen to be, that's how you can zoom in somewhere other than just on the origin. So it's coming. Here we go. There we go. And so to solve this, you do second function trace, which is the calculate menu. 5 is intersect. It'll ask for the first curve and mention it up there. Yes. Second curve. Yes, that's the other one. Guess, please. We only have one intersection point, so it should identify the only one on the screen. So solve for x graphically. Here's the intersection point. This intersection point is not the answer. Okay? Please do not write this whole point as the answer. The answer is just the x value, guys, right? So the x value to the nearest 2 decimal places, negative 0.72. Okay? So x equals negative 0.72. And on a test or something, you would probably be asked to sketch the graph. So you should sketch that graph and show, that you actually did this. And here's your intercept, okay? Negative 0 point intersection point. All right, so what I'll do right now is from chapter 8, if you're asked to do this same thing algebraically, you'd have to use logs, right? So this is how you do that using logs. So you take the log of both sides, log of 6 to the negative x, and because we have a product here, you should separate that as log 3 plus log 2x plus 1, and this negative x can come down as a coefficient on this side. So a couple things I would do, I'd get all the x's over to the same side. So the x's are in these two terms. So I'm going to get x log 6 over here. I'm going to get the constant on the other side, negative log 3. This exponent, the 2x plus 1, should come down, 2x plus 1. What's that?
The exponent is x plus 1, 2 is the...
Oh, yeah. Oh, yeah, thank you. I rewrote it wrong here. Thank you. X plus 1. So log of 2. That 2 should be down there. Good. And so let's list log of 2. Okay. Further, this is x log 2 plus log 2 equals negative log 3. So now we're getting close. This is a long process, but we have the x terms here. I'm going to get rid of this one over here, so I'm going to subtract log 2 from both sides as well. And I'm going to factor an x out here. Negative log 3 minus log 2. And then you would divide both sides by this right here. So you can pull a negative out of there if you want. I don't know if you'd need to. You wouldn't need to, but. So this is divided by a log 6 plus log 2. You can simplify that a little bit more if you want with the addition and stuff like that, but you can just plug it into your calculator as well. So is there any other writing mistakes I did there? Does everything look okay? Okay, well let's see if we get negative 0.72. So when I evaluate this now, oops, negative log of 3 minus log 2, let's see what that is, divided by bracket log 6 plus log 2. There you go, negative 0.72, and that's should be pretty almost exactly the same as what we calculated on our intersection point. So negative 0.72. Okay, so that's a little bit of 7 and 8 there with the logs. Any question about that? Okay. I do have some more, sorry?
I typed this exact same thing in and got a different answer. Again.
All right, so number 9 in the cumulative review here, it says expressed in logarithmic form. So this is from chapter 8 here. In logarithmic form. Okay, so when you have exponential form, remember the log is an exponent, and the so the log is the exponent. The base here is part of the log, right? So it's going to be log base 3. We know that. And remember, it's 3 to the power of x. So the log is the exponent. This is what the log equals. And so it's going to be y going to be here. I think it's easier to go from log to exponent than it is from exponent to log. But if you remember that the base of the power is the base of the exponent, there's not too much else you need to figure out. So 3 to the power of x equals y. Over here, same thing for, this is 9a, this is 9b. So the base is going to be 2, so I'm going to have a log of base 2. The power is over here on the other side, a plus 1, and then m is here. And 10a, expressed in exponential form. I think this is easiest because you always start with the base of the log. X to the power of, go to the other side, 4 equals back here to 3. Same thing over here. B is a to the b equals x plus 5. Any questions on that? There are going to be some easy points here on the test for this stuff, right? I'll make sure I have lots of these questions. I'll try. Not lots. Okay, 11, evaluate. Now, these should be, I don't know if these should be done without a calculator. I don't know if you need a calculator for any of these. 3 to the power of what? That's what this is, right? Don't know what this is. 3 to some power equals 1 over 81. Okay, well, if you know, 3 was, if x was negative, that would bring this in the denominator. And then 3 to the power of what? Okay, so here's negative x, right? So 3 to the power of what gives us 81? So 4, yeah. So x equals 4 because 3 to the 4 is 81. So if it's 1 over, that's what we got, 3 to the 4. Well, because this is over 1, like this, or this is under 1, I guess, 1 over. So you want to find what exponent gives you 81, but then you got to make it a negative. So that's all I was trying to say.
So is the answer not negative?
The answer is not, well, no, yeah, the answer is negative because we pulled this down here, so it's negative 4, yeah. Because the answer is negative 4. Yeah, that's right. Okay, so C, let's do C. C looks tough. So 2 to some power equals log of root 5 base 5. Okay, so 2 to some power. I think I can do this pretty easily. 5 to the power of what gives me 5 to the power of 1/2. The value of this is 1/2. Okay, so now I'll try this again, negative x here. I don't know if, oh, actually, what we could do is this. 2 to the x is 2 to the negative 1. Let's do that. That's probably easiest to see. Then x is just negative 1. Need help with that over there? Or are you okay?
No, I'm good.
You're okay?
I closed it.
Sort of. Yeah, sort of. Not bad. Okay, was there a hand up or was that a stretch? Just a stretch? Okay, I'll let that go. Okay, solve for x. Again, these are easy. I think these are super easy. Going from log to exponential, super easy. It's like almost too easy. This is like grade 8 stuff. X to the 4. No, not grade 8? Okay, you're right, grade 6. X to the 4 equals 16. Look at this. Like what? What is that? I mean, that's,
2.
of course it's 2. Now you can write it like this. You're like 2 to the power of 4 is 16. You were just guessing? See, that's how easy it is. You have no idea what you're doing and you guess the right answer.
I didn't know.
Yeah, that was seriously just a blind guess? See, that's how easy this is. Grade 6, no, grade 1. Grade 1. What about C though? What about C? Can you guess what C is? Off your hand, what is it? No, it's too long. 5? 5? Really? Okay, well, let's just see. C looks pretty tricky, I don't know. So 5 to the power of log of x base, that looks like a 5, I think. Is that base 5? What is that? Is that base 5? Is it base 3? I can't read that. It's 5? Wow. I'm getting old. I can't see that. All right. So, okay. So how are we going to do this? Should we put it in log form? Should I don't know. Like, looks like there's a log already there. I don't know. I know. Why don't we put 1 over 125 as a base 5?
5 to the negative
5 log x base 5 equals 5 to the power of what?
negative 5.
Negative 3?
Yeah.
So 5 squared is 25. 25 times 5 is 125. So that's 3. So now look, we have the same bases. So now I can rewrite like this. Log of x base 5 equals negative 3. And now in exponential form, voila, 5 to the negative 3 equals x. X is?
Negative 1 over 125.
1 over 125. Oh my goodness. That's freaky.
Whoa.
5 to the power of log of 1 over 125 base 5 is 1 over 125. Wow. Beautiful. Okay, anything that you guys are working on you need help with from chapter 7 or 8? I have a word problem here, but I don't know if you guys want a word problem or if you want something else. Yeah. 10b on what? Huh? 8.3 10b?
Yeah.
Did I do 8.310 already?
Or 20B.
Or 20b or all of my assignment? Okay, so yeah, so what you can do is log, they're all base 11, that's good. X times, this is x to the 5 over 2, and this is over root x, right? And this is log of x to the 7 over 3. Okay, so what you can do is work on this first, which might be best. This is 2 over 2, right? So that's going to be 7 over 2 minus 1 over 2. See, this plus this is 7 over 2 minus, this is a 1/2, 1 over 2. So that's going to be 6 over 2 or 3. So this is actually log of x cubed when it's all said and done. And I'll let you take it from there. Okay? So then you just have 1.
If you didn't have the same base, would you have to find?
If you didn't have the same base, you couldn't do all this these special log properties, yeah. It wouldn't work. So the subtracting logs with different bases, that wouldn't work. You couldn't combine them using these rules. It has to be
And now we
has to be
just
same
doing
base.
this now, right? Like you just.
Yeah, you can combine this into one log and then
Yep.
yeah. So you wouldn't be able to do this. If this was like log base 12 or something, then you wouldn't be able to combine it. Just that's it.
Yeah.
You're done. Yeah. Okay, so just as you're studying tonight, please remember MrMathWell.com, chapter 7. Here's all the homework, and here's all the videos for you. I do a review for chapter 7 here, as well as some homework questions. As well, there's a chapter 8 review right here, and the questions I did today will go up here as well in the chapter 7-8 review. So I'll be adding another line here for those ones I did today. So please look through, watch anything extra that you need help with. Yeah, come talk to me at lunch or whatever too if you need help. But tomorrow is your exam, so we will be doing chapter 9 right after that.
Can you put the homework assignment out?
Yep, homework assignments are here.
Is all arrows